That tiny, almost invisible hole in your airplane window isn't a defect, a drain, or an oversight. It's a precisely engineered feature, absolutely critical for your safety at 35,000 feet. This unassuming detail solves a monumental engineering challenge that could otherwise tear a plane apart. When you're cruising thousands of feet above the ground, the air outside is incredibly thin and cold, with very low pressure. But inside the cabin, the air is pressurized to simulate an altitude of roughly 8,000 feet, providing enough oxygen for you to breathe comfortably. This difference creates an enormous outward force on the aircraft's fuselage and every single window. To put that into perspective, the pressure difference across a single window can be equivalent to the weight of a small car pressing outward every minute of the flight. That's a staggering amount of stress. So how do airplane windows withstand this relentless assault of outward pressure? They aren't just a single sheet of reinforced glass. In fact, each airplane window is typically composed of 3 distinct panes, each playing a vital role in maintaining structural integrity and passenger safety. The innermost pane, the one you can touch, is primarily for insulation, sound dampening, and protecting the more critical layers from scratches or accidental impact. It's not designed to handle the massive pressure differential. The 2 outer panes, however, are structural. The outermost pane is the primary load bearer. It takes the brunt of that incredible pressure difference between the cabin and the thin air outside. Directly behind it is the middle pane, which acts as a crucial failsafe. It's designed to withstand the full pressure load on its own, should the outer pane ever fail. This layered design is a key to aircraft safety, but it's incomplete without understanding the role of that small hole. And this is where that tiny hole comes in. You'll find it exclusively in the middle pane, between the outer load-bearing pane and the inner protective pane. Its primary job is ingenious. It's a bleed hole, or breather hole, and it meticulously manages pressure. By allowing air to flow freely between the small gap separating the middle and outer panes and the cabin itself, the pressure in that cavity remains equal to the cabin pressure. This ensures that the outermost pane bears virtually all of the pressure differential. Why is this important? Because engineers want the stress of the cabin pressurization to be consistently and predictably applied to a single, specifically designed component. It's about concentrating the load where it's best managed. If the outer pane E were to crack or fail, the middle pane would instantly become the primary pressure barrier. The bleed hole ensures this secondary pane is ready to take over without any delay, as it wasn't already sharing a partial load. Essentially, it keeps the middle pane unburdened and ready to act as an emergency backup. But the hole has another, secondary function. It prevents fogging. We all breathe, and small amounts of moisture can accumulate in the air gap between the panes, especially with temperature changes. The tiny hole allows this moisture to escape, keeping your view clear and preventing condensation from obscuring the critical structural elements beneath. So that small, almost unnoticeable detail isn't just a simple vent. It's a precisely calculated component in a sophisticated system designed for extreme conditions. It ensures both the clarity of your view and the unwavering structural integrity of your flight. Ultimately, the tiny hole in your airplane window is a testament to the elegant, redundant engineering that underpins everyday safety, often hidden in plain sight. It's a silent guardian, ensuring the immense forces of high-altitude flight are managed with precision. What other overlooked details of our modern world are actually critical marvels of engineering?